Assalamualaikum warahmatullahi wabarakatuh. Today we are going to present about preparation of laundry soap and bath soap using waste cooking oil. Introduce our member. My name is ADRIANIS AFNI and my friend NOORSHAMEERA NATASHA, Fatin Khadijah and MOHAMMAD RADZI.
Hello, my name is Fatin Khadijah binti ROSLAN and I will present to you the abstract of our project, which is preparation of bath soap and nourish soap using waste cooking oil. Used cooking oil can be used to prepare bath soap and nourish soap. Used cooking oils, also known as UCOs, that is discarded from restaurants and household after frying foods, and it can be used to prepare bath soap and nourish soap after filtered. Bath soap is prepared using UCOs, that specifically vegetable oil, that purified with brine solution. Brine solution is a high concentration solution of salt, usually sodium chloride, and bleached with hydrogen peroxide, and then mixed with animal fat, commonly beef tallow. Laundry soap were prepared using UCOs that comes from any type of oils. To prepare both bath soap and laundry soap, it will go through a process called saponification, where the triglycerides from the used oils saponified with sodium hydroxide and AOH by hydrolysis. There were remarkable improvement of the soap's physical properties, and it is equivalent with the psychochemical properties of the commercial soap products. It is advocated that used cooking oils can be used to prepare premium laundry soap and toilet bath soap.
Okay, now I will proceed to introduction. About the background, making soap from used cooking oil is the one of improving other people's general lifestyle. This practice is suitable for residents to remote locations with standard of living. Due to the large amount of cooking oil produced, they decide to produce soap that was useful for their life. This is started when clumps of light lazy material were floating in the water as the Roman ladies carried their laundry to the river. The women bathed their clothes on rock after soaking it in water. The garments become cleaner when the lazy material was pounded with the clothes. For your information, used cooking oil have the same composition as animal fat. The study concludes that used cooking oil can be a soap-making substance. Figure 1 shows that a general scheme of soap preparation or saponification processes. Okay, the saponification process is triglyceride react with caustic acid and make glycerin plus soap. About the problem statement, the production of soap from cooking oil is aimed at addressing waste management problem. This is due to the fact that using cooking oil that have been used for cooking or frying in food, restaurant, and household processing industry have caused waste to be disposed of in the environment after repeated use. This causes many problems such as sewage and clogged septic residue and increased organic load in water bodies. This also pollutes water and soil. The used cooking oil can cause many health problems such as heart disease, stroke, liver disease, eczema disease, and good house disorder. About the research objective, the objective of the study is to reduce the waste of used cooking oil that can cause many problems and also to find another alternative that can replace palm oil in the laundry soap formulation. This study also finds a way to prepare bath soap and laundry soap using used cooking oil that is suitable with the human body and follow the International Organization for Standardization standard.
Physicochemical tests and experimental duties. The physicochemical characteristic can be determined by some factors such as its pH, moisture content, frequency alkalinity, and total fat matter. pH values, also known as acidity and basicity, can be defined as the degree of acidity or basicity of a solution, while moisture content of the soap can be referred to as the quantity of water in soap. The free caustic alkalinity is the quantity of free caustic alkali expressed as a percentage m over n of sodium hydroxide. The formula to find free caustic alkali FCA equals to 0.31 over W multiplied with VA. And total fat matter is the total amount of fatty matter that can be separated from a sample after splitting with mineral acid, usually HCl. The formula of total fatty matter is 100 minus with MC plus MIA over 1.085. The analysis of psychochemical properties of the soap is done using standard procedures reported in literature and is repeated 3 times.
Now I will be explaining about the determination of iodine value, saponification value, free caustic alkali, and chloride content. First, let's take a look at the iodine value. Iodine value is the amount of iodine in unit gram that has been absorbed by 100 gram of oil or fat. The formula given is B minus S multiplied by M multiplied by 12.69 over W. Next is saponification value. It can be defined as the amount of potassium hydroxide (KOH) in unit milligram that is needed to saponify 1 gram of fat. The formula given is S minus B multiplied by M multiplied by 56.1 over W. Next, free caustic alkali. The free caustic alkali can be referred as the quantity of free caustic alkali expressed as a percentage M over N of sodium hydroxide. The formula given is FCA equal to 0.31 over W multiplied by VA. Finally, chloride content. The chloride content is the quantity of sodium chloride NaCl or potassium chloride KCl expressed as a percentage by mass M over M. The formula given is liter volume over weight of soap multiplied by 0.585.
So now we approaching to the sector of result and discussion. The greater the value of iodine, the more uncertainty and the higher the susceptibility to oxidation. Therefore, the iodine values of UCO samples have been analyzed using procedures reported in the literature. It has been reported that the lowering the value of iodine improves the stability and good for yield for liquid oil. The value obtained from the analysis is lower than the value reported in the literature. In addition, the observed of oil iodine value was lower than the pump oil iodine value reported. This can indicate the UCO could be used as a suitable raw material for soap making. The high saponification values indicate that the oil samples are normally triglycerides and will be useful in soap production. In addition, the lower the saponification value, the greater the molecular weight of the fatty acids in the glycerides or the number of ester bonds. The pH value studied for the soap provided are within the range of 9.31 plus minus 0.81 to 10.56 plus minus 0.44. In this case of commercial sample, the pH value is within the range of 2 until 3. These values are comparable to each other but relatively more concentrated than the soap ingredient provided in table 2. High pH value induced incomplete hydrolysis presence. It can be overcome by adding excess fat or oil or any other superfatting agent to reduce soap hardness. Superfatting can help prevent cracks in the soap bar. Superfatting can help prevent cracks in the soap bar and produce excellent foaming. Superfatting can help prevent cracks in the soap bar and produce excellent foaming properties. Skin-friendly soap and fabric are pH within the range of 9 until 11. Moisture content. Reports indicate that moisture content, which is MC, is parameter used in assessing product life. High MC values in soap will cause excessive water response with non-contaminated fat. The analysis result in the study show that MC soap from UCO obtained from the lowest hotel and UCO from the street food seller is highest. These differences may be due to differences in the chemical composition of the oil. The level of heating and the frequency of reuse of oil for frying is different in hotels, restaurants, and street food sellers. The obtained data indicate that the value of the MC provided is below the EAS derived limit. Which is 30% for soap. This indicates that the soap provided can be used for cleaning purpose. Total alkali content is one parameter that determines the abrasiveness of any given soap. The data obtained for the prepared laundry soap determine that the total alkali to be in the range of 0.78 plus minus 0.02% to 1.09 plus minus 0.05%. And the commercial laundry soaps used in the test were in the range of 0.47 plus minus 0.01% to 0.78 plus minus 0.01%, as shown in the table 6. The data obtained for all the prepared soaps are slightly higher than the values obtained from commercial soap used in the experiment, which is shown in table 6. The results obtained in the current study are all below the value set by ISO. Specification that states for soap should have only below 2% of alkali content.
Next is the cleaning action and lathering formation. Cleaning actions such as cleansing power, bubbly, creamy, hardness, and conditioning, and also lather formation are the major characteristics that usually used to evaluate the quality of laundry soap. Lather is a frothy white mass of bubbles produced by soap when it is mixed with water. This characteristic can be described based on the fatty acid composition of the oils that are used in the formulation of laundry soap. Saturated fatty acid like myristic acid and lauric acid can produce laundry soap with high cleansing power and fluffy leather. To evaluate the cleansing power of the soap prepared from its cooking oils, cotton clothes is stained with chicken sauce and being cleaned using those laundry soap. As a result, soap produced from UCOs that were collected from restaurant, hotel, and street food vendors are shown in the table 8. Based on the table, soap that prepared from UCO from hotel has a medium cleansing power and medium lathering formation, while soap that prepared from the cooking oils that collected from restaurant has good cleansing powers and medium lathering formation. Soap that prepared from the UCOs from street food vendor has high cleansing power and good lathering formation. Meanwhile, for the commercial soap brand Sky has medium cleansing power and high lathering formation. Soap brand Leah has poor cleansing power and high lathering formation, while brand Piccolo has medium cleansing power and good lathering formation. It was found that the cleaning powers of the soap were found to be relatively better than the commercial soap samples such as brand Sky, brand Leah, and brand Piccolo. However, the results showed that only soap samples prepared from these cooking oils collected from street food vendors showed comparable lateral formation with commercial soap, which is Piccolo brand. In this method, Sky and Leah soaps were found to produce very high lateral formation compared to the prepared soap. The obvious difference can be attributed to the method used for soap preparation and also natural type of fatty acid composition of the oils used in the soap preparation, while some commercial soap also have foam stabilizer which helps to foam stay longer. Therefore, fatty acid composition of the oils used to prepare soap materials need to be determined before soap preparation in order to get adequate chemical information about the soap to be prepared. The observed properties of the soap prepared from UCOs are comparable with that of the commercial soaps used in study, which suggests type of oils that can be used to prepare good grade laundry soap. Continue with the interaction of bath soap with skin barrier. Surface active agents, also known as surfactants, are the essential cleaning substances. Surfactants indicates the cleaning and lathering characteristic of the soap, including its compatibility and other features. Surfactants stir up activity on the surface that being cleaned to help trap dirt and remove it from the surface. Surfactants have a hydrophobic, which is water-hating, tail, and a hydrophilic head, which is water-loving. The hydrophobic tail of each surfactant surrounds solids. The hydrophilic head is surrounded by water. The hydrophobic tail group, which attach to the greasy soil, which is dirt, and hydrophilic polar head group, which associate with water, helps disperse and rinse away dirt. Soap was discovered many years ago and it has been used for cleaning skin for millennia. The progression of skin cleansing over time is shown in the table. Over the 3,000 before centuries, they are using Java soap. At the year of 1880, they are using industrial soap. In the year of 1940, they are using Hessian soap. In the year of 1950, they are using synthetic bars and liquids. While in 1980, people are using biodegradable soap. While in 2000, people are using conditioning soap. And the latest one is 2012, people are using HM polymer soap. Skin is the layer of usually soft, flexible outer tissue covering the body and is the largest organ of the human body. Skin protects the body from harmful substances and microbes from the environment and also has immune sensory functions, which helps to regulate body and vitamin D synthesis. Skin is the 16% of the total human body weight, thus should be treated with care and respect. The purpose of the skin cleansing is to reduce the sebum, which is oil inside the skin, and exogenous contaminants and control the odors and the skin microbes. However, repeated washing skin with soap and surfactant can negatively impact multiple functions of the epidermal barrier. As you can see, based on figure 3, it shows that how surfactant within a cleanser can remove threatened corneum, SC materials, and also remain in the SC. SC materials is ceramides, cholesterol, and fatty acid which is naturally placed inside our skin. From the figure, the molecular level on the right illustrates further SC lipids, as I said, ceramide, cholesterol, fatty acid, and surfactant from cleanser medium inserting into the skin barrier lipids. To maintain the skin barrier during cleansing, it is the best to maintain the original lipids and the native skin structure. Polymeric species which interact with surfactant creates less aggressive cleansers.
Conclusion: the preparation of bath and laundry soap is beneficial for both the environment and to fulfill human needs. It will lessen the environmental pollution by minimizing the disposal of used cooking oils, UCOs, and replace the expensive cost of using palm oil and animal fats in soap preparation. In addition, it not only does the prepared soap give good cleaning effects, but it is also proven to clean better than those commercial soaps from markets. Based on scientific research analysis, the physical-chemical properties of the soaps prepared from UCOs are compatible with the commercial soaps. The analysis results also indicate that UCOs is suitable in making laundry and bath soaps in such good quality in both small and large scales.